Welcome back, welcome back, welcome back. Welcome back to Jackson Square. Today we'll be finishing up the rest of this multiplying and dividing integers with models concept. So, quick reminder, open circles will be positive, shaded circles will be negative. We need a positive and a negative to make a zero pair. So let's jump right in. When we talked about multiplying, we had groups of something. What is division going to look like? Well, here we have some division problems, and division is going to be a bit different. Instead of having groups of something, we're going to be taking a number and splitting it into groups. Because remember, division is about sharing and dividing. One for you, one for me. One for you, one for me. One for you, one for me. So we're going to be splitting up things and dividing. So we're going to just jump right into this as always. First is 9 divided by 3, which we're going to rewrite it as 9 split into 3 groups. Okay, so we're going to group these. Division is about grouping. So 9 split into 3 groups. So first, this is a positive 9, so I'm going to draw 9 circles. And then I want to take these 9 counters or circles and I want to put them in groups of 3. So I can go horizontal, and this can be 1 group, and then this can be 2 groups, and then this can be 3 groups. Okay? So this one is a little bit different than when we're multiplying. So remember, when we're multiplying, we want to know how much total, like what do we have all together? When you're splitting and dividing, we want to say, if I'm saying 1 for you, 1 for me, 1 for you, 1 for me, how much do I end up with? Or how much do you end up with? What's in your final group? So when we're grouping this 9 split into 3 groups, I just want to know what am I getting in one of those groups? So in one of those groups, I end up with a positive 3. There are only 3 counters and they're positive. So my answer would be a positive 3. So we're only looking at what do you end up with in one group. Okay, so in one group, I end up with positive 3 counters. Okay. The next one says negative 9 divided by 3. Negative 9 divided by 3. So negative 9 divided by 3 is going to be similar to the last one. It's going to be negative 9 split into 3 groups. Negative 9 split into 3 groups. So we are going to have 9 shaded in counters. Okay, and then we want to take those 9 lovely, lovely counters and we want to break them into groups of 3. 1 group, 2 groups, 3 groups. And excuse me. Thank you. Thank you. So I have 3 groups. These look weird, like some kind of sciencey amoebas or something, right? So I have 3 groups of, 3 groups of 3. And again, in division, I want to know what's in that one group. So in one group, if I just took my attention here, what's in one group? In this one group, I have 3 negative counters because they're shaded. 3 negative. So negative 9 split into 3 groups will give us a negative 3. That's what we end up with in the end. So take a second and look at number 4 and number 5. How are they different? How are they alike? Okay. Let's look at the last one. This one is going to be negative 6 split into two groups. Negative 6 split into two groups. So I'm going to have 6 shaded counters. And I want to take these counters and I want to break them into groups of 3. So into groups of 3. Sorry, I want to break them into 2 groups. Thinking ahead. I want to break them into 2 groups. 1 group, 2 groups. And remember, this is division, so we want to know how much do you end up with in one of these groups. So in one of these groups, I end up with 3 negatives. So a negative 3. I end up with 3 negatives. So again, take a second, look at these. What similarities do they have? What differences? Do you see any patterns? Patterns. You see a pattern happening here. Let's talk about how division looks on a number line. So I'm bringing back some of our multiplication problems. Multiplication and division on the number line look quite similar. They're going to have those jumps. You're going to be jumping in groups of something. However, division looks differently. You probably will not see a lot of division problems on the number line. But if you do, I want to prepare you. If you do, this is how you know it's division. Division will always start at the number. It will start at a number that's not 0, and it's going to make its way back to 0. So here I use this model for multiplication, and I change the problem to 10 divided by 2. I want 10, and I want to break it into 2 groups. So if I broke 10 into 2 groups, each group, remember, this is one group would have 5. One group would have 5. Okay? So it will start at 10, my first number, my dividend. Your arrows would start at your dividend, and then it would make its way back to 0. So in multiplication, addition, and subtraction, we start at 0 and go to our sum, our difference, our product. In division, you're working your way back. So that's one way you can know the difference. So this black line represents the division model. See how the arrow is going back towards 0? So that would be division. Okay? Here's one more. So this was a multiplication. I changed to negative 6 divided by 2. So we would start at negative 6, and then you would have 2 jumps or 2 groups back to 0. So in each group, I have negative 3. I'm jumping by negative 3 because I'm going from negative 6, 5, 4, 3, and then 3, 2, 1, 0. So I'm jumping in 2 groups and groups of 3. So again, division will start at the quotient and it will make its way back to the 0. So this is how division looks differently from multiplication on the number line. So again, anytime you see those jumps, you know 1, it's either multiplication or division, and then 2, you try to see if it starts at 0 or starts at another number and goes back to 0. That's how you know if it's division. Okay? So hopefully while we were modeling multiplication and division, you start to see some kind of pattern. You guys love rules. You're always trying to make up some rule. So what pattern did you see? Hopefully, I hope you saw this pattern. And here's a little brief table, multiplying or dividing. It says if the signs are the same, then the answer is positive. Okay, so a positive times a positive gives you a positive. A negative times a negative will give you a positive. Same with division. A positive divided by a positive is a positive. A negative divided by a negative is a positive. Okay? So I hope you guys notice that. If the signs are different, then the answer is going to be negative. Okay? A positive times a negative is a negative. A negative times a positive is a negative. Or a positive divided by a negative is a negative. Or a negative divided by a positive is a negative. So, little quick way we say, same sign, same sign positive, different sign negative. That's it. Same sign positive, different sign negative. So hopefully you noticed that. And if you did not notice it, I'm going to bring these back so you can look at them. So positive times a positive, our answer was positive. A positive times a negative, our answer was negative. A positive divided by a positive, my answer was positive. A negative divided by a positive, my answer was negative. Same sign positive, different sign negative. So let's jump right into some practice today, working on division of integers with models and any other strategy that we might have up our sleeves. Good luck.